In the diagram, points A, B, C, and D are on a circle. Philippe uses a ruler to connect each pair of these points with the line segment. How many line segments does he draw? One will be from A to B, one will be A to C, and A to D. The next one will be from B to C, because B to A is already counted with this guy, and then B to D, and then the last one is C to D. If we make any more, it will be just doubles. So these are just the unique ones, and that's 6 of them. What is the smallest positive integer, n, for which the square root of 2019 minus n is an integer? So if 2019 minus n is an integer, I have to sort of get an estimation of what that number could be. So, and we want the smallest, so we want this as close to 2019 as possible. So let me just see what is 2019 square root. When I do that, I get about 44.9. So let me see, 45 squared is 2025, and 44 squared is 1936. So obviously, since n is positive, this number inside is going to be less than 2019. So I can't choose this guy, I got to choose this guy. So that means 2019 minus n is going to be the 1936. And when you take the square root, it will be 44. So it will be basically 44. So that means that 2019 minus n is 1936, so I can easily solve. That means n is 2019 minus 1936, and therefore n will be 83. At 7 a.m. yesterday, Sherry correctly determined what time it had been 100 hours before. What was her answer? 7 a.m. So 24 hours prior, it was 7 a.m. And then 24 hours before that was 7 a.m. again. And then 24 hours again, 7 a.m. And then finally another 24 hours, 7 a.m. Now, so far I've gone 24 times 4, which is 96 hours, correct? So I've got to go another 4 more hours to reach that 100. And if I do go back another 4 hours, I will get to 3 a.m. because it's before. So 3 a.m. is the answer to this question. A standard die with 6 faces is tossed onto a table. Ite counts the total number of dots on the 5 faces that are not lying on the table. What is the probability that this total is at least 19? Well, you can have 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, or 6 dots, right? And let's see here. If the 1 dot is lying on the table, then you'd count the other sides, and that would be 2, 3, 4, 5, and 6, and that sum would be 21, right? Hold on, let me think about this. No, sorry, the sum would be 20. Yeah. Okay, so I believe that is the maximum sum. And similarly, if the 2 is lying on top of the table, the sum would be the sum of 1, 3, 4, 5, and 6, and that sum is 19. And similarly for 3, 4, 5, and 6, if those are lying on the table, the sums would be, let's put it here, sum would be 18, 17, 16, and 15. So we have 1, 2, 3, 4, 5, 6 possible sums. So for the probability, we have the total is 6 because there's 6 possible sums, and we want the ones that are at least 19. So the ones that are at least 19 are this guy and this guy. So there's 2 of them that are at least 19. So in lowest terms, I guess the probability is a third. Suppose that A, B, C, D are positive and 0 less than A less than B less than C less than D less than 10. What is the maximum possible value of A minus B, C minus D? Well, since we have a sort of a chronological order, what I'm going to do, just to make this appear positive, is I'm going to factor out a negative 1 and make this B minus A. And then same thing with the bottom, and make that D minus C. And then what that does, it just makes it B minus A over D minus C. And that's just a little bit helpful, I think, because B minus A, since B is greater than A, B minus A will be greater than 0. So this guy is going to be greater than 0, and this guy is going to be greater than 0. So it's easier for me to work with numbers that are positive. So we want the maximum possible value of this guy. Now the maximum possible value of that will be by making this the maximum and this the minimum. So we want to make the top guy as large as possible, and we want to make the bottom guy as small as possible. So our choices for A, B, and C are between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the only choices because A's got to be greater than 0 and D's got to be less than 10, and they're all integers. Okay, so let's fiddle around with this. The D minus C, the smallest I think I can make it is 1. Like for example, if I made this D 9 and C 8, the D minus C would be 1. That's the smallest I could make it, which is what I want. And then for the B minus A, the largest I could make it, if I made that B and I made this guy A, then B minus A would be 7 minus 1, which is 6. And I think that pretty much is what they're looking for, the maximum possible value of that expression with these parameters. When the line with the equation y is equal to minus 2x plus 7 is reflected across the line with the equation x equals 3, the resulting line is y is equal to ax plus b. What is the value of 2a plus b? Well, let's draw a little graph here. And let's see what we have. So let's see here. Y is equal to minus 2x plus 7, right? So when x is 0, let's just put a 7 there. And when y is 0, it'd be 3. Let me think about this. Oh, it's a minus there. I forgot the minus. Oh, minus 2x plus 7. Sorry about that. So it'd be 3.5 approximately. So this is my line kind of like that. And then we want a reflection. So the reflection is in what? X equals 3. So this guy was 3.5. So 3 is about here. So this is the line x equals 3. And then the reflection would be in that one. So it would be something like, I think something like that. That would be the reflection line, reflecting line, whatever. And that's the one that's y equals ax plus b. Okay. Well, a couple of things I noticed is that that point will be on it. So that is when x is 3. And when x is 3, y is equal to minus 2 times 3 plus 7. So y is equal to 1. So 3, 1 is on this line right here. And then another point that's on this line is right here. Well, we can figure that out by symmetry because it's exactly equidistant from x equals 3 on the other side. So this was 3.5. So it's 0.5 going right of x equals 3. So this guy would be 0.5 going left of x equals 3. So that would be 2.5. So 2.5 and 0, since both of those are on the x-axes. So these 2 points are on this, so then we can solve. So that should be fairly straightforward. Okay, so x equals 3, so that means 1 is equal to 3a plus b. And then when we have 0 and 2.5, it would be 2.5a plus b. Okay, let's subtract these, and we get 0.5a. So that means a is 2, and then we sub it back into one of these to get 1 is equal to 6 plus b, so therefore b is equal to minus 5. And therefore, finally, 2a plus b is 2 times 2 plus minus 5, and that is negative 1. Suppose that 2 to the power of 3 all to the power of x is 4096, and y is equal to x to the power of 3. What is the ones units digit of the integer equal to 3 to the power of y? All right, so the 4096, I believe, is 2 to the power of 12. So this is 2 to the power of 3x is equal to 2 to the power of 12. The bases are the same, so that means the exponents are equal. So that means 3x is 12, and therefore x is 4. So now we turn our attention to this guy. Y is equal to x to the power of 3. Y is therefore 4 to the power of 3, and that, I believe, is 64. Okay, and what are they asking for? What is the ones digit of the integer equal to 3 to the power of y? So 3 to the power of y is 3 to the power of 64. Okay. So they want you to find out what is 3 to the power of 64 and then figure out what is the ones digit, the very last digit. But I think we use a pattern here. So 3 to the power of 1, 3 to the power of 2. Let's see what the pattern is. Because I've done a lot of these questions before. These are pattern questions. And you should be able to get this pattern fairly quickly. Okay, well, 3 to the power of 1 is 3. This is 9. This is 27. This is 81. Let's just do a few more. This is 243. And this is 729. And this is 2187. And 3 to the power of 8 is 6561. Now, I want you to look at the units digit, the last digit, ones digit of each of these. Well, it'll be 3971. 3971. So as you can see, the 3971 is the repeating pattern for the units digit for powers of 3. And there's a similar pattern for other numbers, like the units digit for powers of 7 or powers of whatever. So to get 64, you would have to extrapolate. So I think that whenever the exponent is a multiple of 4, the units digit would be 1. So is 64 a multiple of 4? And the answer is yes. So therefore, its units digit will be 1. And that is what they are asking for. Yasmin makes her own chocolate beverage by mixing volumes of milk and syrup in the ratio 5:2. Milk comes in 2-liter bottles and syrup comes in 1.4-liter bottles. Yasmin has a limitless supply of full bottles of milk and syrup. Determine the smallest volume of chocolate beverage that Yasmin can make that uses only whole bottles of both milk and syrup. All right. Well, so we've got M over S, milk over syrup, is in the ratio 5:2, which is 2.5 basically, right? So that means if I just use this, I cross multiply, I get 2M is 5S, right? Okay. But the milk bottles are in 2 liters, so it's really 2 times 2 liters. So 2M, like that, in terms of liters. And a very similar story for the syrup. That comes in 1.4 liter bottles. So this is really 4M is equal to 7S. And to make this equation work with the smallest, right? Smallest is what we're concentrating on. I suspect that M would be 7 and S would be 4. And if that is the case, that would make this equal. So that means that the total chocolate would be 7 bottles of milk, and each bottle has 2 liters, and 4 bottles of syrup, and each bottle has 1.4. So that's 14 plus 5.6, so that's 19.6. And I think this is the smallest volume of chocolate that can be made with only whole bottles of milk and syrup. Suppose that A is an integer, a sequence x1 ... is constructed with x1 equal a, x2k equal to 2x, 2k minus 1, x2k plus 1 equal to x2k minus 1. For example, if a is 2, x1 is 2, x2 is 4, x3 is 3, x4 is 6, x5 is 5, and so on. The integer n equals 578 can appear in the sequence after the 10th term. For example, x12 is 578 when a is 12, when a is 10. But the integer 579 does not appear in the sequence after the 10th term for any value of a. What is the smallest integer n greater than 1395 that could appear in the sequence after the 10th term for some value of a? Okay, so first, let me write down a few of these, x2, x3, and so on. And what are they saying? After the 10th term, so I've got to go up at least to the 10th term. And I will. How much farther do I want to go here? I'll go x11, x12, and maybe I'll go one more, x13. I think that should be sufficient. Now my task is to figure out what is each term for any value of a, because remember, they're saying for some value of a. They haven't given me the actual value, which makes it a little challenging, but that's okay. I think I can figure it out. So let's just start with a, and the next two, basically, depending on these definitions, is 2a. And then it's actually not that difficult. You just subtract 1, so it would be 2a minus 1. And then you're doubling it, so it would be 4a minus 2. And then you subtract 1, so it would be 4a minus 3. And then you're doubling it, so it would be 8a minus 6. See what I mean? It's actually not so bad. Then you subtract 1. You're just either doubling or subtracting 1. Doubling, subtracting 1, like that. So this would be 8a minus 7. Now x8 is doubling. So that would be 16a minus 14. Now you subtract 1, so 16a minus 15. Now you double, so it would be 32a minus 30. And then you subtract 1, so 32a minus 31. And then you, this is the double part, right? So 64a minus 62. And then this one, you subtract 1, so 64a minus 63, I believe. Okay, that's a lot, so I think that should be sufficient. Yeah, that should be sufficient. After the 10th term, so we're really just looking at these guys. Yeah. After the 10th term. Okay, so let's talk about this. And we want it to be greater than 1395, right? All right, so let's see what we get. So I've got to deal with this guy and this guy. And then I've got to figure out the smallest. The smallest. Yeah. Okay, and then I'll just go with that guy. And then after that, it's going to be double that, right? So obviously these three should be sufficient. Okay, let's go for it. The 32a minus 31 has got to be greater than 1395, okay? So 32a is greater than 1425. That means A, use your calculator and you get, what, 44.5. So a is 45, because a is an integer, I believe. Let me just double check that. For any value of, I think at the very, oh yeah, right there, at the very beginning of the question, it says a is an integer. Okay. So then 32a minus 31, which is the actual value, if you substitute a equals 45, we want the smallest, right? So we'll put in 45 minus 31. 32 times 45 minus 31 is 1409. Okay, so now we got to make sure that we get the smallest, so we got to experiment with this guy. 64a minus 62. Let's see what happens when this is set to be greater than 1395. We get 64a greater than 1457, and therefore a is greater than 22.76, so a would be 23. And sub it back into 64a minus 62, and we get 1410. Okay, and then 64a, this guy, 64a minus 63, well, that's just one less than this guy, so it'd be 1409. So the minimum looks like 1409. And then if you go anything beyond x13, you get numbers that are bigger, because the next one, x14, would be double this guy. So then obviously it's not going to be the smallest. So the smallest is 1409 according to these calculations. In the diagram, ABCDEFG is a rectangular prism. Vertex H is hidden in this view. If angle ABF is 40 degrees and angle ADF is 20 degrees, what is the measure of angle BFD to the nearest tenth of a degree? Calculators are allowed, and that's a great thing on this contest because I'm going to use trigonometry. So let's label this. Let's see here. 20 degrees is this guy, right? ADF, yeah, that's 20. And then this one, ABF, is 40. Okay. So I'm going to use tan. Tan of 40 is AF over AB, right? Now, I've got to start this off somehow. So, because in the end, we only care about finding out an angle. We don't care about the sides, really. So I'm going to arbitrarily label something, and I'm going to call AB 10. It doesn't really matter, but I've got to start this off with something. I've got to have some numbers to work with, otherwise I won't be able to figure it out. So I'll let AB equals 10, and that means AF over 10. So AF would therefore be 10 tan 40. Okay. And then BF I will get from the Pythagorean theorem because it's a right angle triangle, right? Because this is right angle. So BF squared would be AF squared, which is 10 tan 40 all squared, plus BA, which I've labeled 10. And then when you crunch out these numbers, you will get 13.054072 approximately. Okay. So now then use the exact same methodology for this guy over here. We're going to use tan 20 this time, and that's going to be AF over AD, and AF I think we already got, right? It's 10 tan 40, and AD we don't know. So that means that AD is equal to 10 tan 40 over tan 20. Okay, not the prettiest, but that's okay. Let me just put a box around that since that's important. Now we use Pythagorean theorem again. Let me see if I can keep that in the same screen, because that is kind of helpful to keep it in the same screen. Pythagorean theorem again to figure out DF. Yeah, the hypotenuse of that triangle. So DF squared is AF squared plus AD squared, right? Okay, so that means AF, do I have AF somewhere? Yeah, it's right here. So that's 10 tan 40 all squared, and AD is right here. So that's this big long song and dance, 1040 tan 20 all squared. And then you can crunch out these numbers and figure out that DF will be 24.5336. Okay, and then again, in a very similar way, you would figure out BD, which is going to be AB squared plus AD squared. And AB I had set at 10. AD, where was AD? Oh, AD is here. So it's 10 tan 40 over tan 20 all squared. And so then when you crunch out those numbers, BD will be 25.1294. Okay, so I've got all three sides. Now, how do I get this angle? And which angle were we trying to get again? BFD. So I'm trying to get this angle right here. BFD, this one. Okay. Well, let me just draw that. So we've got this triangle, and this is B, and this is D, and this is F. And we're trying to get this angle, call it theta. And we know this is the side lengths. We know that BF is 13.054072. This guy right here. BD is 25.1294 approximately. And DF is 24.5336 right here. Correct? So how do we figure out the angle? Well, that screams cosine law. And some of you may remember, some of you won't, but that's okay. BD squared would be BF squared plus DF squared minus 2 times BF times DF cos theta. And that's the math. So let's plug in all these numbers. So BD squared is 25.1294 all squared. BF is 13.054 all squared. Plus DF, which is 24.5336 all squared. Minus 2 times BF 13.054 times DF 24.5336 times cos theta. So there you go. You crunch out these numbers, which I'm sure you can, and you'll get a cos theta equal to 0.2198. And when you take the inverse function and figure out the angle, it's 77.3. And that is the answer to this question.